Okay, so today's 5-7 day 2, triangles and coordinate proof. Alright, today we're going to bring in the distance formula, okay, to do some coordinate proofing. So for those of you who don't remember, the distance formula is as follows. D equals square root of the quantity of x2 minus x1 squared plus the quantity of y2 minus y1 squared. So remember, the biggest challenge is making sure we fill this in correctly. Alright, so coordinate proofs use figures on the coordinate plane to prove geometric concepts in theorem. Alright, so we're proving concepts and theorems today. Remember, this is conceptual and not exact numbers. Alright, so we're going to write a coordinate proof. So write a coordinate proof that shows that triangle FGH is congruent with FDC. Alright, and we have the coordinates for each. So use the distance formula to find the length of each side of each triangle. If the sides of the triangles are congruent, then the triangles are congruent by SSS. Alright, let's fill in the distance between D and C. Alright, so it looks like they put D first, so let's fill in C. Remember, we're doing X. Alright, that's negative A. And then Y is 0. Alright, so remember, negative times a negative is a positive. So negative A plus A, well, that just gives me, they cancel each other out. So that's 0 squared. Plus, alright, and then we've got B minus 0, well, that's B, so that's B squared. Alright, square root of the whole thing. Well, squaring and square rooting, if you remember, cancel each other out. Alright, squaring 0 is 0, and those cancel each other out anyway, so nothing plus B. Well, that's just B. So from D to C is B. The length is B. Alright, let's check out G to H. Alright, G to H. Looks like they put G first, so let's see, our X of H is A. And the Y is 0. A minus A, well, that gives me nothing. Alright, and nothing squared is still, well, nothing. So let's see, the square root of, well, B minus nothing is just B, and square it, so the square root of B squared and squaring and square rooting cancel each other out, so again we're left with B. So the length of GH is B. Hey, these are the same. Alright, because DC equals GH, side DC is congruent with side GH by the definition of congruence. They equal each other, they have to be congruent. Alright, that's direct enough. Now let's do some more sides. DF, alright, DF. Alright, and they did F first, so let's fill in D. The X is minus A, the Y is B. Alright, so negative times a negative is a positive, so this would be nothing plus A is A, and that's A squared, so A squared. Alright, got it. Okay. Plus. All right. We've got b divided by 2 minus b, and the whole quantity is squared. So let's pull that out over here. So b divided by 2 can be rewritten as 1/2 b. Okay, they're equivalent. Minus 1b. All right, 1b. So if I have a half minus 1 whole, well, that'd be minus 1/2 b. Okay. Squared. All right, so let's distribute to the top, to the bottom, to the variable. So 1/4 b squared. Okay. So we've got 1/4 b squared. Okay. Well, let's see what else. Well, we could put this back to b squared divided by 4. Okay. So you can go back and forth. All right. So plus b squared. All right. Now, you know that squaring and square rooting cancel each other out, except we have a squared plus b squared divided by 4. It would only cancel out if everything was squared. That makes sense, but everything in here is not squared. So we have to leave it the square root of a squared plus b squared divided by 4. Okay. We have to leave it like that. So that is df. So this is the square root of a squared plus b squared divided by 4. Okay. GF. All right, GF. G is already in, so let's do F. X is 0. B over. Okay. So this would be 1 whole minus a half. Well, that's a half b squared. All right. And then plus a minus nothing is, well, that's still a. That's a squared. So when you distribute all that, which we've already done, you still end up with a squared plus b squared over 4, because -1 squared and 1 squared is still 1. All right, so we've already done the math here. So from g to h is also the square root of a squared plus b squared divided by 4. And I'll just do CF. All right. Let's see, CF. They have got FN. Let's fill in C. So our x of C is -a. And that is 0. Okay. So negative times a negative is a positive. So that's, again, a squared plus b squared, b over 2 squared. All right. So, and again, can't lose our radical. All right, so that's still the square root of a squared plus b squared over 4, because b squared. 2 squared is 4. Alright. Square root of a squared plus b squared divided by 4. There's that one. Last step. HF. Alright, it looks like they have HN. Let's put in F. 0. B divided by 2. So again, a squared plus negative b divided by 2 squared. So again, we're left with the square root of a squared plus, well, negative b squared is b squared, because negative times a negative is a positive, and 2 squared is 4. So these are all the same. These are all the same. Okay, df equals gf equals cf equals hf. So that means side df is congruent with side gf, which is congruent with side cf, which is congruent with side hf, and because all of these sides are congruent, alright, if the sides of the triangles are congruent, then the triangle are congruent by SSS, side, side, side. So all of our sides are congruent, so our triangles are congruent via SSS, side, side, side. Alright, again, conceptual. Conceptual. We're working with concepts here. Alright, number 4. I'm going to change pen colors. No particular reason. I just feel like it. Here, we'll go with pink. Alright, so we're going to prove a theorem. We're proving a theorem by using coordinate geometry. Okay? We're going to write a coordinate proof to show that if two lines are each equidistant from a third line, then the two lines are parallel to each other. Alright, so what do we have? AB and EF are equidistant from CD. So this one's the same distance as this one is from the same line. Alright, so it wants us to prove AB is parallel with EF. Okay. And we're going to prove that. It says slope. So if you remember, slope is your change of y over your change of x. Fudge. There we go. Alright. Change of y over change of x. So AB. 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 Alright. X1, Y1, X2, Y2. Fill in your formula. B minus 0 over A minus 0 is B over A. That's my slope. Slope of EF. Slope of EF. Alright. Again, change of y over change of x. EF. Alright. Change of y. Y2 is B. Y1 is 0. Y2 is 3. I mean, X2 is 3. A. And X1 is 2A. So again, B divided by A. And definition of parallel lines is they have the exact same slope. Alright, because the slopes of line AB and EF are the same, line AB is parallel to line EF. Alright, remember, parallel lines, same slope, perpendicular lines, opposite reciprocal slope. All right, again, conceptual. All right, let's use this knowledge. Okay, let's use this knowledge. And we're going to use this knowledge on the back. See your distance formula? We're going to use that. See, use the distance formula. So we're going to write the distance formula again back here, just so we have it visually on our back. So the distance formula equals the square root of, all right, x squared minus x1, the difference of your x's squared, plus the quantity of the difference of your y squared. All right. Navigation. The Polynesian Triangle is a triangle formed between the three Pacific island groups that form the South Pacific region, also known as Polynesia. The approximate coordinates in latitude and longitude of each vertex are Auckland, New Zealand, there are its coordinates, Honolulu, Hawaii, with coordinates, and Easter Island with its coordinates. All right. Got triangle. All right. Coordinates. It says use coordinate geometry, which is what we've been working on the last couple of days, to determine the type of triangle formed. Ooh, types of triangles. All right. Use the distance formula to determine the length of each side of triangle round to the nearest tenth. Okay, so we're going to use our distance formula to determine what kind of triangle this is. So, in the distance formula, if all sides are the same, that means they equal each other. That is an equilateral triangle. All right, we've done that. We talked about equilateral triangles. We proved that when we were doing 5-6. All right, equilateral. If only two sides of the three are the same, which means only two sides equal each other, that's the isosceles. Okay. Again, 5-6 day 1 and 2, we talked all about isosceles versus equilateral, and we worked on the distance formula to prove isosceles, equilateral. But what if no sides are the same? All right, so if no sides are the same, that means none of them equal each other. That is your scalene triangle. That doesn't get much love in math. All right, we don't talk about it a lot. We spend a lot of time talking about equilateral and isosceles, but we got this poor redhead stepchild scalene triangle. No sides are the same. Okay, so none of the sides are going to be equal. Well, visually looking at this triangle, it's hard to tell. All right, so again, the state EOC, they're going to give you stuff. It's going to be out of the context of our nose, so it's not going to be in isolation. Everything's going to be all mixed in, and you have to be able to determine, okay, which type of triangle is it, using your ever-loving distance formula. All right, so we're going to put things in, use our distance formula. We've got this. It just takes some time. We got this. All right, so what do we want to do first? Okay, so we're going to go from New Zealand to Honolulu. We're just going to do them systematically, okay? All right. A, H. All right, this is 0.1, 0.2. All right, so 0.2 x 21.3 minus 0.1 x, oh, that's also negative 40.9 squared plus, all right, the y of my second point, y, minus 157.9 minus the y of my first point, 174.9. Well, that's squared. All right, let's do a little math. Remember, we're rounding to the nearest tenth, which is one place to the right of the decimal. All right, so my little handy dandy calculator. Alright, so negative times a negative is a positive. 21.3 plus 40.9 equals 62.2 squared. Alright. 157.9, make that a negative, minus 174.9 equals, oh, that is a negative 332.8. Alright, let's square these. Alright, so 62.2 times 62.2, because I don't have a squaring button on this, is 3,868.84 plus. So much fun. Alright, we're going to square this negative number. Negative times a negative is a positive. So 332.8 times 332.8 equals 110,755 and 84 hundredths. Okay. So we're going to add 3868.84. Alright, the square root of 114,624.68. I do have a square root button, hit that. And that equals, we round to the nearest tenth. Okay, by looking at its neighbor, 6 is 5 or above, 5 or round up, so 338.6. Okay. So that is the distance here, from here to here, 338.6. I like to mark it on my map, so I know I did it. I'm going to change colors, just because I want to go now from Honolulu to Easter Island. Alright. First point, second point. Alright. Formula. Alright, so my x2, second point, that's E, my x2, minus 27.1 minus my x1, first point, Honolulu, 21.3. Alright. Alright, H, E, Y2, second point E, Y2, minus 109.4 minus Y1, first point H, Y1, minus 157.9. That whole thing is square root. Oops, 2. Okay. Now let's do this math. Alright. Calculator back. Alright, so 27.1 minus 21.3. There we go. Alright, 5.8 squared. Negative times a negative is a positive. So 109.4, that's a negative, plus 157.9 equals 48.5. Square that. 5.8 times 5.8 equals 33.64 plus 48.5 times 48.5, 2,352.25. Alright, let's add those together. Plus 33.64, 2,385.89. So let's do the square root of that. Alright, okay, again. Rounding to the nearest tenth, based on its next door neighbor, which is 4. So that holds where it is, so it's 48.8. 48.8. I feel like I did my math wrong somewhere. I probably did. I am sure someone is going to tell me on Friday where I went wrong, because I'm sure I went wrong somewhere, because that doesn't seem right. I am sure I did. Like I said, please, on Friday, someone tell me what I did wrong. We're going to keep going, though. Okay, so next up, I'm going from E to A. Alright. E to A. Oh my goodness. Alright. First point, second point. X2 of my second point minus 40.9 minus my X of my first point, the X of my first point minus 27.1. Alright, Y2. A Y2. 174.9 minus Y1. Y1 minus 109.4 squared. Negative times a negative is a positive. Negative times a negative is a positive. Alright. Alright, let's see. Next step. Alright, so 40.9 negative. Negative times a negative is a positive. 27.1 minus 13.8 squared. Alright, 174.9. Negative times a negative is a positive. 109.4. 284.3 squared. Alright, let's square some numbers. 13. Negative times a negative is a positive. Times 13.8 equals 190.44 plus 284.3 times 284.3. Jesus. 80,826 and 49 hundredths. Alright. Almost done. We're going to add to that the 190.44. 81,016.93. Find the square root of that. Round to the nearest tenth. Based on the hundredths place, that's below 5, so this holds. 284.6. Again, I'm pretty sure I did my math wrong somewhere. I'm thinking I did my math wrong somewhere here. It happens. Again, someone tell me on Friday how I did my math wrong, because I know it's wrong somewhere. I don't have time to figure out where it's wrong. But I do know we're making our main point is that we were supposed to classify this, and we were supposed to use distance formula. And these are all different. Even if one of them is wrong, they are still all different. And because they're all different and no sides are equal, this is a scaling triangle. All right. So, you have an assignment online. Good thing is, I don't think there are any of these on there, but I did need to make you aware of that. You will have to use the distance formula. All right. But we needed to go through what makes the different triangles and how to prove it. All right, just saying, state test. It's going to be on there. But the bulk of your assignment, though, comes from these two examples. All right, good luck.